Welcome back. In today's video, we're going to look at reviewing some factoring techniques. We're going to look at factoring out our GCF, which stands for our greatest common factor. We're going to look at factoring trinomials, where the lead coefficient is 1 and when the lead coefficient is something other than 1. So we have x squared plus bx plus c, and then we'll also look at trinomials that look like ax squared plus bx plus c. Again, in the first one, the lead coefficient is 1. In the second, we will look at trinomials where the lead coefficient is something other than 1. And then we'll start looking at factoring special binomials. If you remember from your lecture videos, that includes difference of squares, sum of cubes, and difference of cubes. Factor out the GCF of 3x squared minus 6x. We want to look at both the coefficients and the variable component of this expression. Looking at our coefficients, 3 and 6, the GCF is going to be 3. And if we look at our variable components, x squared and x, the GCF is going to be x. So altogether, our GCF for this expression is 3x. Once I've written my GCF, I can actually sit here and make these division problems and simplify those fractions. That might help you in seeing how to simplify and get the next factor of your expression. 3x squared divided by 3x is x. Negative 6x divided by 3x is negative 2. And that's factoring out the GCF. Let's look at the next example. 28ab cubed minus 16a squared b plus 20a cubed b squared. Now we have 3 different components we want to look at when we're trying to determine the GCF. First, we'll look at the coefficients, 28, 16, and 20. What is the greatest common factor of those 3 constants? It is 4. A squared, a cubed. The greatest common factor of those 3 terms is just going to be a. Remember, your greatest common factor is something that will divide evenly into all of your terms. B cubed, b, and b squared. Again, we will have just a GCF of b. To see clearly what we will get when we factor the 4ab out, we can divide all of our terms by that 4ab. 28ab cubed divided by 4ab. 28 over 4 is 7. A divided by a is 1. B cubed divided by b is b squared. Negative 16 divided by 4 is negative 4. A squared divided by a is a. B divided by b is 1. Plus 20 divided by 4 is 5. A cubed divided by a is a squared. B squared divided by b is b. That's all that factoring is. It's a process of dividing out a common factor. Let's look at some examples of trinomials where the lead coefficient is 1. X squared plus 14x minus 72. Many of us remember that in order to factor this, we're looking for factors of c, which in this case is negative 72, that sum to b, which is 14. So we can use our calculator to do some trial and error. Just take 72 and start dividing it by numbers until you come up with the answer that's going to work. For this one, our factors are going to be 18 and negative 4. Because c was negative, one of our factors is positive, the other is negative, and we have to make sure that when we add them, we get positive 14. This is one of those steps that you want to be very careful in, that your signs are correct. When I add 18 and negative 4, I get 14. And now I can go straight to my 2 binomials, starting with x, and then I use my 2 factors to fill in the binomials. Plus 18 minus 4. And to check, all you have to do is FOIL it back out. X times x is x squared. X times negative 4 is negative 4x. 18 times x is 18x. And 18 times negative 4 is negative 72. When we combine like terms, we get x squared plus 14x minus 72, which is what we started with, so we know that we factored correctly. x cubed minus 18x squared plus 80x. First thing we recognize is that there is a GCF that we can factor out of all of these terms. That GCF is x. So we've got our x out front, and I'm going to go through and divide every term by x. Drawing these separate fractions helps me in identifying how each of those terms are going to simplify. X cubed divided by x is x squared. Negative 18x squared divided by x is negative 18x. And 80x divided by x is just positive 80. And now we have left in the parentheses that quadratic trinomial with a lead coefficient of 1. So we're looking for factors of 80 that sum to negative 18. Now we want to, again, pay attention to signs. Factors of 80 that sum to negative 18. Since they multiply to give me a positive, that means they're either both positive or both negative. Since the sum is negative, that indicates that both of my signs are going to be negative. So looking at this, I know negative 8 and negative 10 will multiply to give me a positive 80 and will add to give me negative 18. So I can split my trinomial into two binomials, x minus 8 and x minus 10. Again, to check, you would distribute the x into the first and then refoil, and you will find that we got what we started with. Now let's look at a few examples where the lead coefficient is not 1. 2x squared minus 7x minus 9. The first technique I'm going to show you is called trial and error, and this might be the technique that you guys learned in high school. We know that it's going to end up looking like this. Now this trial and error method is essentially working back and forth between factoring and foiling. If I think about foiling, the first two terms are going to multiply to give me the 2x squared. So if I'm thinking about two things that multiply to give me 2x squared, they are 2x and x. Now the last two pieces are going to multiply to give me negative 9. So what are some factors of negative 9? We have 3 and 3. So we can try that. When I FOIL out my middle terms, I'm going to get 6 and 3. 6 and 3 is not going to combine to give me negative 7. So let's try something else. How about 9 and 2? Now again, we're going to FOIL out to find our middle terms. 2 times 9 is 18. 2 times x is 2. So 18 and 2, again, we're not going to get that middle term of 7, so that doesn't work. But maybe we're starting to see that if I just switch those, maybe that will work. Oh, I'm sorry. Maybe I've done this wrong now. Let's start all over. Maybe I've been saying the wrong thing this whole time. All right, from the beginning, we have our two binomials. Again, our first two terms need to multiply to give me 2x squared. That's 2x and x. And this is where I was making a mistake on that last step. The factors of 9 are 9 and 1, not 9 and 2. Excuse me. So if I do the 9 and the 1, that's my 18. This is my 1. Again, 18 and 1 are not going to give me 7. If I switch those two, make this a 9 and this a 1, now we've got 2 and 9, and that we can work with. 2 and 9 in some combination could give me 7. Now let's pay attention to our signs. We need a negative 7 and we need a negative 9. So I've got 2x and 9x. If I want them to add up to negative 7x, I want the 9 to be negative and the 1 to be positive. Negative 9 times positive 1 gives me that correct sign of negative 9. So you can see that the trial and error method, you have a lot of moving parts and you have to keep track of them. If you're already accustomed to doing this, that's fine. You can use this technique. It works just fine. Just be prepared that with trial and error, you might have quite a few trials and quite a few errors before you get to that final answer. Now, the technique that I'm going to show you, which I prefer, is called the AC method. We start just like we did in the previous example where we're finding factors of something that sum to something else. In this case, we are looking for factors of a times c, hence the AC method. In this case, a times c is 2 times negative 9, which is negative 18. And we still want them to sum to b, which is negative 7. So thinking about factors of negative 18 that sum to negative 7, that we can see as negative 9, positive 2. Those add up to negative 7. So at this point, we haven't really changed our technique that we used in the previous example. Now we're just multiplying by a times c first. The next step is the step that most students forget in the AC method. So I'm going to mark it with an asterisk. What we're going to do is we're going to take our original quadratic and rewrite it, splitting up this middle term. So I've got 2x squared plus 2x minus 9x minus 9. First, I want you to notice that if we were to combine like terms here, we still have the original problem. Okay, we see that. Now, the next thing I want to know is, where did we get these two values, the 2x and the negative 9x? Where did those numbers come from? How did I split it that way? That comes from our factors of negative 18 that sum to negative 7. At this point, we have our quadratic, the same quadratic we started with, but now it's written a little differently. And now we're going to continue to factor. When I have a polynomial that has 4 terms, our only option for factoring is to factor by grouping. If I look at my first group, 2x squared plus 2x, I can factor out a 2x, and I'm left with x plus 1. Negative 9x minus 9, anytime that lead coefficient is negative, you want to ensure that you factor out the negative as well. So we're going to factor out negative 9, and we're left with x plus 1. Factoring by grouping, we know we're on the right track if these parentheses are the same. Since they are the same, we can factor out the x plus 1, and our other factor is 2x minus 9. You can see that we got the exact same factors as when we tried the trial and error method. It's up to you which technique you like the best. I will always show AC method. For me, it's a bit more systematic, and that's how I like to approach problems. But use whatever you feel most comfortable with. If you have another technique and you want to show me in class, I welcome that as well. 15x squared minus 91x plus 6. When we look at this, we might be thinking GCF here. Look at your first and your third factor, or your first and third terms. 15 and 6, we know both have a factor of 3. So let's check negative 91. Is negative 91 divisible by 3? When you get your calculator out and you enter that in, you'll find that no, it is not divisible by 3. So there is no GCF for this trinomial. So when we start factoring, we're going to go ahead and jump straight to the AC method. So we need factors of 15 times 6. 15 times 6 is 90. That sum to negative 91. Again, we wanted factors of these two values that sum to negative 91. Factors of 90 that sum to 91, negative 90 and negative 1. Multiplying two negatives gives me a positive. Negative 90 plus negative 1 is negative 91. And now I rewrite my quadratic. Again, this is the step that we need to make sure we don't forget. 15x squared. I'm going to split the negative 91x to negative 90x and negative 1x. Let's do negative 90x first, negative 1x second, plus 6. The arrangement of those two terms doesn't matter. You'll find that if you switch it around, you'll still get the same factors at the end. Now we factor by grouping. 15x squared minus 90x. Both of these are divisible by 15x, and I'm left with x minus 6. Negative 90 divided by 15 is negative 6. Negative x plus 6. Again, because we have that negative, we want to make sure we factor it out. And I'm going to write negative 1. Don't just factor out the negative. It will help you in our next step. So if I divide both of these terms by negative 1, I'm left with x minus 6, which is good because now my two parentheses match. So my first factor is x minus 6. My second factor comes from the 15x minus 1. Now for this problem, trial and error is going to be even more tricky because when you look at 15x squared, there are more than one set of factors that multiply to give me 15x squared. When you look at 6, there are more than one set of factors that multiply to give me 6. So you've got a lot of different combinations you'd have to check to make sure that you get negative 91x for your middle terms. Let's look at some special binomials. We'll start with a difference of two squares. We know it's a difference of two squares because we've got the x squared, 16 is a perfect square, and the minus sign. We know that difference of two squares factors to x plus 4 in this case times x minus 4. The rule that we saw, a squared minus b squared factors to a plus b, a minus b. That's the rule or the model that we use. In the second example, 9x squared minus 25y squared. Again, we've got two terms. We've got a binomial, an x squared, a y squared. This is more than likely a difference of two squares. 9 and 25 are both perfect squares. We're good to go. So if I look at this, 9x squared is the same as 3x quantity squared. 25y squared is the same as 5y quantity squared, which is giving us the value of our a and our b. Now we can just plug those in to the model. This factors to 3x minus 5y, 3x plus 5y. In the next example, x squared plus 8, we're actually using a sum of cubes. So let's review that formula here. We've got a cubed plus b cubed. What does that factor to? Well, from our notes, we know that it's a binomial times a trinomial. In trying to remember these formulas, I recommend first setting up what I call the skeleton. The skeleton are the two pieces, or the terms. A squared, AB, b squared. Now, the reason I tell you to set up the skeleton is because in our next example, we're going to see the difference of two cubes, a cubed minus b cubed, and the skeleton is the same. AB, a squared, AB, b squared. So we set up our skeleton, and then we just have to determine the signs. The signs follow the acronym SOAP. S is same. O is opposite. And AP stands for always positive. Now, how do we use this to determine our signs? We have 3 signs in each of our skeletons. The first sign is always the same as the original problem. The second sign is always the opposite, and the third sign is always positive. For the next one, same, opposite, always positive. So as long as you can remember the skeleton and SOAP, the rules for sum of cubes and difference of cubes are quite easy to remember. So I'm going to erase this and go back to our original problem. X cubed is the quantity x cubed, and 8 is 2 cubed. That helps me identify my A and my B. And I'm plugging into my skeleton. We've got a squared, which is x squared. I'm sorry, not a squared, just a. AB, a squared, AB, b squared. And now we can fill in our signs using SOAP. Same, opposite, always positive, and then simplify just so that our answer looks nice and pretty. X plus 2 times x squared minus 2x plus 4. Let's look at a difference of two cubes. X cubed minus 27. X cubed is the quantity x cubed. 27 is 3 cubed, which identifies our A and our B. Plug into your skeleton. A, B, A squared, AB, B squared. And then SOAP, same, opposite, always positive. And then last but not least, simplify. X minus 3 times x squared plus 3x plus 9. When you guys get into college algebra, we'll actually start looking at ways of I'm losing my train of thought. Ways of deriving this formula. You won't always have to have it memorized if you know some other tools. So that's pretty handy, but obviously in this case, just knowing the formulas are what's going to be key for moving through this next unit. To wrap up our review on factoring, first thing you want to make sure you do always is check for a GCF. If there is a GCF, you need to factor it out. One, because that completes the factoring, but two, it also makes factoring quite a bit easier. When we factor out a coefficient, a number, it typically makes the rest of our coefficients smaller, so that's nice. We looked at factoring where the lead coefficient is 1. When the lead coefficient is 1, we find the factors of C that sum to B, and we jump straight to our two binomials. When the lead coefficient is something other than 1, then we've got some options. We can either use the trial and error technique that I showed you at the very beginning, or you can use the AC method. Depending on what type of a learner you are, if you like things more systematic, I encourage you to practice with that AC method and get very good at that. Then we also looked at a couple special binomials, difference of squares, difference of cubes, and sum of cubes. Those three formulas you guys are going to need to know and be able to recognize those binomials and apply those properties in factoring in our upcoming unit. So we'll see you guys next time when we start looking at rational expressions. Thank you.